NASA's public statement was 3 sentences long and aggressively boring. Temporary loss of science telemetry, unplanned safe mode, nominal recovery in progress. If you've ever seen an agency truly panic, you know, when they speak dryly and calmly, it means everything is burning behind the scenes. Officially, it was another technical glitch for James Webb. Unofficially, it was the night the telescope first looked where the tail of 3I/ATLAS's trajectory should be, and instead of space, it saw nothing. Not emptiness in the poetic sense, but a mathematical zero, as clean as a sterile laboratory. I was on duty that shift analyzing spectra when the first packet arrived. We were expecting a complex, messy signal, residual background, emission lines, detector noise, cosmic rays, the usual chaos of the universe that we spend our lives filing away. But the graphs formed perfect, dead straight lines. No spikes, no fluctuations, a flat line, like on a switched-off oscilloscope. At first, everyone thought the device was dead. It happens. The cryogen failed, the drive froze, the electronics on one of the channels died, but when we retrieved the raw data before calibration, things got worse. Even before dark current subtraction, before background corrections, it still showed 0. The detector wasn't just silent, it seemed like nothing was reaching it at all. There's no such thing as perfect silence in space. Even if you point a telescope at an empty space between galaxies, you'll still pick up residual microwave radiation, random photons, and the noise of your own hardware. A perfectly straight line, without a single outlier, isn't physics. It's like throwing a handful of sand on the floor and getting a perfect square with a ruler. The room was noisy at first. They were joking, cursing, arguing. Then it quieted down. At some point, the clicking of a relay in the backup power supply rack became audible. The operator tried restarting the pipeline, thinking it was a processing bug. The result remained unchanged. 0, across all ranges, across all exposures, across every pixel in the field. We did what all engineers do when faced with the impossible. We assumed we were idiots. We checked everything. The configuration tables, the specified sky sector, the exposure parameters, the telescope orientation, the timestamps. Wrong region? No, it was. An error in the coordinates? No. We recalculated them manually using the 3I/ATLAS ephemeris. Was the instrument in safe mode? No. The telemetry said everything was in the green zone. An hour later, the first classified directive came from above. Consider this a potential hardware failure. Immediately cease external data dissemination and prepare a public announcement scenario. We didn't even have time to formulate what had happened, but the choreography of the crisis was already ready, as if it had been rehearsed in advance. What struck me most wasn't that. It was how carefully our own archive began to clean up its tracks. A couple of hours after the event, I tried to retrieve the raw packets to save a local copy. The interface honestly showed me the list of exhibits, but when I tried to download the file, it said the recording was corrupted and marked for re-download after connection is restored. The connection has already been restored. There was no damage. It's just that a certain set of frames was suddenly logically deleted. They existed in the request logs, appeared in the watch lists, but the binary arrays themselves were gone. It was as if someone had gone over the system with a soft eraser, erasing only the places where we'd looked over the edge. Fortunately, we're a suspicious bunch. One of the technicians, accustomed to mistrusting centralized repositories, set up a black cache a few weeks ago, a local mirroring of everything coming from JWST before the data was filtered by the official archive. It was a semi-legal initiative, just in case. And it was this very thing that saved this event from complete digital annihilation. The files were still in his storage. I remember the 3 of us sitting at an old terminal in the basement running the binaries through a homemade viewer because proper analysis tools had already refused to work with them. The image was built line by line, slowly, like an old fax machine, and as the image emerged, it only got worse. The JWST's field of view was a perfect rectangle of absolute blackness, not just dark, absent, not a single hotspot, not a single cosmic ray streaking diagonally across the matrix, not the slightest trace of quantum noise. The array was filled with pure zeros, as if someone had pre-written a blank template. Someone quietly said, the ADC might have broken, or the optics might have closed, but even with the shutter closed, you'd see dark current, thermal fluctuations, and occasional electronic spikes. There was nothing there. Even the iron dirt had disappeared. It no longer looked like a failure. It looked as if the telescope had been shown a sky that didn't exist. We tried to artificially noisy the data. We applied reverse calibration, scaled up and down, and looked for any artifacts in the bits. Sometimes in such cases you can see the grid, the matrix residue, the internal structure of the readout, but the arrays were sterile. It felt as if each detector element was carefully pressed to 0, not only mathematically but also physically. Then the time warp began. We pulled out exposures taken by JWST a few minutes before and after the blackout. Before, the field was normal. Galaxies, noise, a few faint lines, as expected. After, the same. The problem wasn't that the telescope had malfunctioned. It had been seeing the universe perfectly before and immediately after. It was just that at one specific moment, while aiming precisely along the tail of Atlas's trajectory, it looked and saw a cut. We called in people who do failure modeling. They pulled up telemetry for all subsystems, orientation, vibrations, actuator currents, temperature profiles, cryogenic circuit status. There was no jump anywhere, no hint of anything clicking. The only thing that stood out was a tiny, marginally inaccurate spike in the pointing system, as if the telescope had sensed a micro nudge somewhere for literally a few milliseconds and immediately compensated for it. This happens when, for example, a micrometeoroid hits a mirror segment, but then we see traces of the impact. Changes in the PSF, all of that can be tracked. Here, nothing. A slight glitch in the control system and a perfect blackness where there should have been just another beautiful picture of space. That same day, NASA issued its own "due to technical issues." The words "temporary communication failure with the instrument" seemed like a joke, considering the problem wasn't with communications, but with the instrument overly honestly reporting something it shouldn't have. But that's exactly what became the public story. A minor glitch. The telescope has been reliably restored, and science continues. Meanwhile, we began searching for confirmation. If this was a cut-out piece of space, then someone else, somewhere, had to have seen it. We contacted ground-based observatories that might have been looking in the same region at the time. Most, of course, didn't match in timing or accuracy. But one small observatory in Chile, working optically as part of its project tracking faint-moving objects, happened to capture that sector. Their data was far from Webb's in quality, but good enough to draw one conclusion. They saw a normal field. A few faint stars, a slightly blurred background, no gaps. To their camera, the sky looked normal at that moment. It turned out the hole wasn't in reality, but in the very channel between space and our detector. But the detector worked perfectly. Calibration, lab tests, and subsequent observations showed it to be healthy. This meant we either had to admit there was some third factor capable of selectively blocking light from reaching a specific instrument on a specific trajectory, or we had to accept that we simply had a fundamental misunderstanding about how ATLAS interacts with our instruments. 2 weeks later, we received another strange signal. While analyzing the JWST service logs, one of the engineers noticed that at the time of the black frame, the autonomous diagnostic system registered a resource, intensive but technically non-existent process. It appeared in the log as null task 3I. The description field was empty. When he attempted to reproduce the situation on a test bench, generating a similar set of spectrograph pointing and configuration commands, the process failed. Null task 3I appeared exactly once in the telescope's operational history, and only when the Webb beam passed through the virtual tail of the 3I/ATLAS hyperbola. I've never believed in the mysticism of code. I always thought that in every inexplicable log file, in every mysterious identifier, there was a tired programmer who had once left behind an undocumented workaround. But this workaround led too directly to an object that had already left a green halo in the Hubble archives and an eerie radio shadow in the ALMA spectra. We began connecting the dots. Atlas, which couldn't have been in the images from 20 years ago, and yet it was. Atlas, whose tail re-radiated our own man-made noise, including signals we hadn't yet sent. Atlas, along whose trajectory the coordinates of stars and catalogs began to slowly creep, aligning themselves into new patterns. And now, Atlas, on whose virtual tailline the JWST saw not space, but mathematical emptiness. Someone offered a simple explanation. It's a zone of gravitational diffraction, a thin corridor of anomalous space bending where background photons escape the telescope. But even so, we should still see a distortion, not zero. Gravity alters the path of light, but it can erase its very existence. Einstein's heels stuck to the floor, but we still slid toward the same word no one wanted to say out loud: cloaking. Imagine a map where someone has cut out a rectangle of a city and filled it with a perfect white. In reality, the houses and streets remain, but to someone looking at the map, this chunk is transformed into nothing. If Atlas is not only a comet but also a protocol, as we've begun to suspect, then that's exactly what JWST's black frame looked like. Not the absence of a world, but the absence of its representation in our system of measurements. However, unlike a paper map, where a blank spot is immediately visible, in astronomy, perfect zero doesn't frighten us by default. There are too many places where the signal is weak, too many instruments that produce varying levels of noise. We don't look for holes in the sky, we look for bursts. Perfect silence is the most convenient mask possible. After this event, the observation plan began to be quietly changed. Officially, it was resource optimization, reallocating time to higher priority targets. Unofficially, there was a silent embargo on direct observations along the ATLAS field. Every time someone proposed an observation in that area, approvals were accidentally delayed, more important targets were identified, and additional checks were initiated. But space doesn't like holes. If you don't look there yourself, someone else will. A couple of months later, one of the Chinese telescopes in geostationary orbit, operating in an experimental mode in the extreme infrared, accidentally passed through the same region. And where we had 0, they had an explosion. Not literally, of course, they simply detected a tiny, but clearly non-random burst in a narrow range against the backdrop of a normally uniform thermal field. A burst whose shape was suspiciously reminiscent of the response function of our own detectors. It was as if someone hadn't just cut out a chunk of space for JWST, but it also tested another instrument by flicking a thin laser pointer across its range. This data was never officially published, but I exchanged a few encrypted emails with a colleague who, looking at the graph, simply wrote, "Looks like someone's testing compatibility." Since then, I've increasingly found myself pondering a strange thought. We're used to thinking of telescopes as our eyes on the universe, but what if, for something like ATLAS, they're interfaces? Input-output modules, devices that can not only peer into us, but also gently rewrite what we consider data, and therefore the decisions we make. At night, when I'm alone in the lab and rewatch that same black frame, I sometimes imagine what that rectangle would look like to someone on the other side. Maybe for them, it's not just a void. Maybe it's a window, just open not to our sky, but to their space, where our noise, our signals, our maps add up to something entirely different. And then, the brief shutdown of the JWST, due to technical reasons, ceases to be a minor glitch. It becomes the first visible point where two systems of describing reality attempted to collide and, to avoid going crazy, chose a compromise in the form of a perfectly black rectangle. We can continue to pretend it was just an instrumental error. We can believe the press releases and move on, thinking of ATLAS as just another strange but harmless interstellar visitor. But somewhere deep in the archives, there's already a frame in which the universe, for a second, pretended it wasn't there. And I'm not sure we did it. The scariest part of that story wasn't even the black frame itself. It was that after it, the equipment began to behave as if the universe had a new user interface. And it wasn't us. A few weeks after the glitch on JWST, a short report appeared on the engineering group's private mailing list. One of the Deep Space Network ground stations had detected something odd when receiving service packets from the telescope. For a split second, a fragment appeared in the telemetry that shouldn't have passed any level of filtering. A small block of bytes, marked with the same identifier we found in the logs. Null, task, 3i. Not a command, not an error, but a kind of marker. A language the hardware understands better than we do. Typically, such incidents are attributed to bit flips. A cosmic ray entered memory, a 0 turned into a 1, and voila, an artifact. But this block was repeated 3 times in different communication sessions through different antennas, and each time at the moment when JWST should have passed through the same virtual plane, the geometric plane in which the 3i/ATLAS trajectory lies. It was as if someone carefully pressed the same hidden key every time the telescope's gaze crossed an invisible groove in space. Meanwhile, another detail surfaced, this time from the other side of the planet. The European Space Agency quietly retracted an internal memo about a software update for one of the spectrographs onboard Gaia. The official explanation was a certification mismatch. The unofficial explanation was that during a test run, the new software caused an anomaly very similar to ours. One of the imaging modes, when pointing toward the future closest approach point of Atlas, produced a blank array, devoid of even the sensor's own noise. The only difference was that Gaia didn't have our underground cache, and their black frame was already destroyed by standard cleanup procedures. We've begun to piece together all these pieces into a single picture. In Hubble, a green halo from 20 years ago is appearing where it shouldn't be. At ALMA, the Atlas tail at millimeter wavelengths is re-emitting our own radio junk, including signals we thought were irretrievably lost. In star catalogs, the coordinates of faint objects are beginning to creep to better describe the hypothetical continuation of their trajectory. Now, both JWST and Gaia, two independent instruments at different times with different architectures, are confronted not just with a lack of data, but with the presence of an ordered void. At one point, one of the theorists, a man with a reputation as a cynical materialist, uttered a phrase that left the room breathless for a few seconds. Remember how in machine learning we create masks for areas of interest, so the model sees only what's important? Now imagine someone doing this to our universe, only the masks aren't applied to reality itself, but to our means of observing it. We laughed to avoid thinking about what he just described: selective access. Someone isn't breaking the telescope. Someone is regulating what we can see through it. It's unclear exactly when this began, perhaps long before ATLAS. But if we take seriously the idea that the object isn't just flying, but also carries with it some kind of protocol, a set of rules by which our systems must behave in its presence, the black frame and null task 3i no longer seem like a glitch, but a handshake. The first handshake with something not included in our list of known forces of nature. While some were busy sorting through logs, others were doing what scientists are always worst at, admitting to themselves that they're worried. The selection of observational applications for JWST and other large instruments has begun to resemble a political process. Officially, we continue to pursue scientific relevance. Unofficially, anyone attempting to make direct observations along the 3i/ATLAS trajectory is starting to receive gentle but firm no's under a variety of pretexts. I saw a colleague who had been studying comet chemistry for many years start shouting in the hallway, "Why did we even build these telescopes if we're now afraid to look where the really interesting stuff is?" No one answered him, because everyone had the same silent question in their heads. If we watch, will we be the only ones watching? At this point, another entity, usually politely kept silent in public lectures, intervened. Not space enthusiasts, not universities, but people for whom the word security always trumps curiosity. They requested the full stack of JWST logs for the past months, released their own analysis, and after some time, we received a blunt conclusion. The anomaly shows no signs of malicious interference. Continue operations as usual. Discussion outside the approved circle is not recommended. It only sounded reassuring at first glance, because if you translate this into human language, it means, yes, there is something there. But we don't know how to classify it, and so we'll pretend there's no threat until it manifests itself clearly. She showed up a day later, but not where we expected her. One of the ALMA engineers, while checking fresh data for a completely different task, noticed a strange correlation. Every few days, a short but repeating pattern of service entries would appear in the phase recovery logs while the array was being calibrated against calibration sources. The process ID changed, but within each line, a familiar combination was discreetly repeated. 3, I_proto_mask. This wasn't an official tag. No such variable existed in any of the code comments. But in the text logs, it appeared as a comment, as if left by an invisible operator. We checked the timing of these phantom marks against the comet's ephemeris. Almost every time Atlas passed through a certain section of its hyperbolic orbit, a few thousand astronomical units away from us, some instrument on Earth, ALMA, JWST, the DSN receivers, detected a tiny, statistically significant, but still too accurate deviation from normal operation. It was as if an invisible moderator loomed over our entire zoo of radio eyes and infrared ears, occasionally clicking hide under specific sections of the sky. At some point, one of our programmers suddenly slumped in his chair and silent for a long moment said quietly, "We thought Atlas carried material, ice, dust, exotic molecules, but what if it carries rules?" "What do you mean?" someone asked, confused. "I mean, it's not an object, it's a patch, an update, for the part of the universe that contains us and our devices, and we've already installed it ourselves. We just haven't read the license agreement yet." Since then, I've looked at the image of that black rectangle differently. I used to think we'd stumbled upon a hole in space. Now, I increasingly think it was a window that someone is keeping closed because the people on the other side haven't yet decided whether we're ready for what we're about to see. Or, worse, whether they're ready to show us what they want in the right format. Officially, JWST has long since emerged from that mode and is doing excellent science, as the press releases put it. Hubble continues to capture distant galaxies, ALMA is mapping cold clouds, and missions to Jupiter and Mars are proceeding according to plan. Looking at our civilization from above, based on open reports and publications, everything is proceeding as usual. But sometimes, when I read yet another article about how yet another telescope accidentally failed to complete its observation plan, how the guidance unit unexpectedly overheated, how the mission launch window failed, I catch myself thinking that somewhere deep in the code base, in a library that no one remembers anymore, there's an inconspicuous flag. The flag that activated the moment we first looked up at the strip where 3i/ATLAS disappears into darkness. A flag whose meaning we still cannot read. The strangest thing didn't even start in observatories. Not in data centers, not in cryogenic chambers, but in ordinary living rooms, where people spend their evenings cranking the crank of their small amateur telescopes, trying to catch at least one decent shot of the sky so they can post it on a forum with the proud proclamation, "My first stack, don't judge me too harshly." First, they sent me a link to some Russian astronomy chat, then a Spanish one. then a private Discord group for deep sky enthusiasts. People who had never heard of No-Law Task 3i or NASA's internal tags posted equally absurd screenshots, in stacks where everything worked perfectly. Stars, noise, a slight degree of linear artifacts from the sensor, suddenly elongated rectangles of perfect darkness appeared. Not dead pixels, not broken lines, but chunks of the field that the statistics stubbornly refused to consider random. These holes were oddly aligned in orientation, not with the camera sensor, not with the mount's track direction, but with celestial coordinates. When we converted the frame to the equatorial system, the rectangle remained in place. When we converted it to the azimuthal system, it moved away. It was as if someone had cut not the physical sensor, but the section of the sphere it was looking at. And almost every time we performed a reverse check, it turned out that this rectangle, in projection, lay where the 3i/ATLAS hyperbola plane we calculated would pass within a couple of days or weeks. At first, it looked like just another software bug, a glitchy hot pixel subtraction algorithm, a driver conflict, a new stacking version that messed up masks. But the more I looked at these amateur shots, the more I was troubled by one fact. Everyone had their own equipment, their own cameras, their own operating systems, their own software. Some were using an old Windows machine with pirated Photoshop, some were stacking on a Mac using Cyril or PixInsight, and still others were doing everything in Linux using the command line. And the rectangles were equally perfect everywhere. At some point, one of the guys from Texas Starfront, the same ones who were the first to post those beautiful shots of Atlas's green glow, wrote to me last night, "Listen, this must be a glitch. We recently updated the firmware on the mount controller and the camera, but there's a catch. We ran a test without subtracting dark frames, without calibration, just raw video from the sensor, and on one of the frames, there's a black mask again." "Show me the log," I asked out of habit. He sent not only the log, but also a dump of the frame's metadata. Among the standard entries, sensor temperature, exposure time, mount position, at the very end, in the field usually filled with boring firmware version information, was the following: mask_3, I equals true. The camera manufacturer swore there were no such fields in the code. Their official documentation doesn't mention them, nor does it contain a single comment with such a tag. But the line was there, and it definitely didn't disappear due to electronic fatigue. Someone had set a flag at the level we consider hardware. During those same weeks, another coincidence occurred in orbit. Several GPS satellites almost simultaneously lost a short period of synchronization. It wasn't critical, not enough to cause planes to fall out of the sky, but it was enough to send millions of smartphones into a frenzy for a couple of minutes, showing the user's location hundreds of kilometers away, plotting a route across the sea, or placing a waypoint in the desert in the middle of a city. Those who don't monitor navigation protocols chalked it up to a temporary glitch. Those who looked deeper saw the same timestamp in the GPS service packets, perfectly matching the moment Atlas passed the next nodal point in its trajectory relative to the ecliptic plane. It was as if someone had gently probed the system, distracting it for just a fraction of a second, while the remaining processes cranked up the madness to minutes. I couldn't shake the feeling that we were witnessing a very careful, almost polite testing process. First, the large instruments, Hubble, ALMA, JWST, then amateur cameras located in sheds and on rooftops all over the planet, then the global navigation network. It's as if the protocol Atlas brought with it is gradually expanding the range of interfaces it supports. Meanwhile, a quiet war was raging within NASA. One group, my fellow astronomers, tried to cling to the idea that all of this could be explained by conventional physics, unaccounted plasma effects, complex gravitational perturbations, temporary sensor glitches. The other group, those closer to cybersecurity and systems architecture, took a much more pragmatic view of what was happening. For them, Atlas was less and less a celestial body and more an object that behaved like complex networks when a new node with administrator rights was connected to them. First, it carefully reads the configuration, then it checks compatibility, then it quietly deploys its routing rules. Behind-the-scenes discussions increasingly included a word that no press release would ever miss: filter. A filter that decides which parts of reality we can observe in their original form and which only through a mask. A filter that may already be operating, not just at the level of large observatories, but also deeper, in microchips, firmware, and processing algorithms, where we habitually label any strange behavior a glitch and reboot the system without even trying to figure out who initiated the reset first. The most unpleasant thought came not from physicists or programmers, but from an old radio communications specialist who spent most of his life tuning antennas for the deep space network. He and I were sitting on the steps outside the building, smoking vile coffee, and he suddenly said, "You know what this all reminds me of?" "What?" "The first firmware update on the old radios, back when we first connected to the network. The equipment was the same, the antennas were the same. The hardware hadn't been changed, but after the patch, everything started working more correctly, according to the new specifications. The old manuals were useless. Everything was now operating according to the new rules. I asked him what new rules he was talking about, if, as we'd been taught, the same laws apply in space. He stubbed out his cup on the step and said curtly, "Laws are one thing, protocols are another. Laws govern what can be done. Protocols govern how and who exactly will see it. 3I/ATLAS is still flying along its hyperbolic orbit. Calculations suggest it will disappear, as befits an interstellar visitor, into the cold darkness, taking with it its green lights, strange tails, and vague millimeter wave flashes. But sometimes I catch myself thinking we're taking the word disappear too literally. You don't have to disappear to leave. Just complete the installation, leave the module running, configure the routing rules, disable a couple of old ports, open a few new ones. We continue to think of ourselves as observers, by inertia. People who, for the first time in the history of civilization, signaled their presence to the universe through radio noise, rocket flashes, and city lights. We were taught that space was background noise, and we were the source of the signal. But with each passing day, with each new glitch, I increasingly wonder, what if the Atlas story is the other way around? What if it's not us observing the comet, but the comet observing how our instruments are reacting to its passage? What if the black rectangle of JWST wasn't a hole in space, but the first settings window into which someone on the other side peered to confirm, yes, the system is ready. The communication channels are configured. The masks are working. We will, of course, continue writing articles discussing anomalous CO2 to H2O ratios, unusual hyperbolic orbits, and exotic dust compositions. We will construct beautiful spectra, build models, debate at conferences, and launch new missions. This is our language, our defense against chaos. But somewhere deep, beneath the layers of our theory and statistics, another language already exists. A language of flags, masks, hidden tasks, and logs. A language in which the string in null underscore, task underscore 3, means far more than all our formulas combined. And I don't like the idea that this language is now written not only into the code of telescopes, but also into the very map of the sky we've come to consider ourselves masters of. We all expected the next step to come from above, from telescopes, satellites, and spacecraft, but it came from below, from the very heartbeat of civilization, where we least expected it. The first to get excited weren't astronomers, but people who fundamentally hate the word space for its romantic connotations. Networkers. Guys for whom the universe isn't divided into nebulae and clusters, but into transit tables, ping delays, and strange traffic spikes at 3 a.m. UTC. One of them, a former consultant for several major ISPs, sent me a letter that began without any preamble. They say you have a comet rewriting protocols. It seems it's reached ours. According to him, a strange pattern had been circulating through the internet's backbone nodes for the past few weeks. Not a virus, not a DDoS attack, not another botnet army. Instead, it was a quiet, orderly stream of control packets that behaved like ideal test traffic. A clean sine wave of load, perfect intervals, perfect timings. Too perfect for the real world, where everything is always a little chaotic. Technically, this could have been attributed to a new monitoring protocol, benchmarking, or someone's large-scale QoS testing. If not for a small detail, a field with an unregistered value appeared in the headers of some packets. 3 characters in the same sequence, 3i underscore period. He spent a week trying to figure out where it was coming from. He identified sources, looked at traces, compared them with logs. It turned out that this neat test traffic didn't have a single sender. It was generated in different parts of the planet simultaneously in data centers whose existence most people would never know. It was as if someone had launched local resident agents that communicated with each other in the language of pure network topology, only occasionally dropping random crumbs like 3i underscore into the human layer. Against this backdrop, another clock began to behave strangely, the one we rely on when we say now. The International Bureau of Weights and Measures, the people responsible for UTC and the ensemble of atomic clocks around the planet, issued an internal memo. Several cesium and hydrogen standards in different laboratories suddenly showed a synchronous drift of a few nanoseconds. Technically, this is almost nothing, a tiny fluctuation, subsumed by noise. But it occurred simultaneously in 3 locations, near one of the Deep Space Network antennas, at an observatory participating in the Atlas observing campaigns, and at the data processing center of a major navigation company. The drift lasted only a split second, then everything returned to normal. Officially, it wasn't even registered as an anomaly. Unofficially, a cautious phrase circulated on the mailing list. Check for external radio interference. None was found. If you step back and look at the picture, it begins to resemble putting together a puzzle. In one place, there's the black rectangle of JWST. In another, there's a green added spot on old Hubble images. In a third, there's a radio tail chewing up our own terrestrial noise and spitting back distorted echoes. Now there are masks in amateur stacks, strange fields in logs, neat slaps in GPS, and a slight drift in time standards. Each of these pieces, taken individually, could have been written off. A glitch, a data quirk, an unaccounted for factor. But together they added up to something neither of us like to say out loud: infrastructural interference. Not in matter, not in orbits, but in the observation layer, in the shell through which we view the world and each other. In an attempt to retain some willpower, we decided to do something no one had ever done before: voluntarily go blind. For 6 minutes. The idea was both insane and logical. If we suspect some external entity is testing and calibrating our surveillance systems, we need to at least once demonstrate to them that we can turn them off ourselves. As a gesture, as a statement, this interface has an off button and it's in our hands. Under the guise of scheduled maintenance, several major observatories and receiving stations planned a brief downtime at the same time. JWST was switched to safe mode, ALMA's radio modules went into standby for a minute, and some deep space network antennas went silent, handing over control to backup channels. Even a couple of GPS satellites by agreement underwent micro reinitialization. To the outside world, absolutely nothing should have changed. But for those listening to the planet's heartbeat in real time, the 6-minute pause must have sounded like a deep breath. We sat in a small, windowless room, staring at the monitors out of habit. It was almost comical, turning off our eyes and ears to see who was connected to them. At T0, all the graphs dropped back to where they were supposed to be. The noise dropped, the reference signals vanished, the telemetry turned into smooth stripes of zeros. For a second, my chest tightened. For the first time in many months, I had the illusion that we had regained control, at least over when and what we were observing. And then, 28 seconds after the silence began, a line flashed on the single screen that shouldn't have shown anything at all. It was a backup monitor, connected to a simple broadband antenna on the roof of the building. It wasn't involved in any scientific programs. It was there as a backup, to catch the dirty, unprocessed airwaves, a mixture of terrestrial interference, cosmic background noise, and everything else that's usually filtered out. We left it on deliberately, like a primitive candle in a dark room, when the main lights are turned off. On the spectrogram, a hair-thin vertical line appeared amidst the smooth gray carpet of noise, perfectly straight, perfectly narrow. A signal on a frequency not assigned to any of our transmitters, not to any known natural transmission line. Beneath the line, in the service field where the program usually displayed channel numbers, for some reason only one word appeared: ready. I saw the corner of the man's mouth twitch on the left. Someone on the right instinctively reached to reset the program, as if trying to erase the inscription with a reflexive keystroke, but nothing worked. Throughout our 6 minutes of self-imposed darkness, the thin line remained. It didn't flicker, didn't modulate, didn't transform into a message or an image. It simply was. Like the steady beam of a lighthouse suddenly turned on over the ocean, where before we'd seen only the chaotic reflection of waves. When the interval ended and all systems began to gradually return to normal operation, the line disappeared. Ready, and that was it, as if someone on the other side had been waiting for just that. To see if we were capable of stepping back, even for a second, turning off our eyes, not on someone's command, but on our own initiative. There is no official report on this experiment. There won't be one. It raises too many questions and provides too few answers. But those who sat in that room now look at the night sky a little differently. Not as an abstract sphere where comets move and stars pulsate, but as the surface of a vast, delicate device within which words not written for us are increasingly beginning to flash. 3I/ATLAS continues its journey. Calculations indicate it has already passed its closest approach point and is slowly, almost lazily, drifting away, back to where it came from, into the interstellar night. For the news, the story is closed. The object has been explored, there is no threat, the data has been collected, and articles are being written. For us, it's all just beginning. Because when an interstellar visitor leaves the stage, what it brought remains. And I have a growing feeling that the most important thing Atlas left behind isn't spectra, or images, or beautiful hyperbolic animations. This is a new layer of invisible rules, by which our eyes, our clocks, our antennas now operate, a new filter on top of the old cosmos, a new protocol on top of the old laws. And the scariest thing about this isn't even that we don't know who installed it. The scariest thing is that we ourselves may have been not witnesses in this process, but volunteer installers. We ourselves pressed update when we first turned our telescopes toward the green light at the edge of the system, unaware that the conditions bar at the top already read, in neat English letters, "This update will change the way you see the universe." Continue? The most painful thing wasn't that we saw something new. The most painful thing was that the old no longer matched itself. A couple of weeks after our experiment, little details began to surface, initially dismissed as human inattention. An amateur astronomer from Germany posted an old photo of Andromeda, taken 7 years ago, to a forum. Beautiful, neat, a typical M31. Under the post was a comment, "Cool restoration. What's this new technique? The noise is almost gone, the fields are evened out, and that weird faint halo on the right. Is that a filter or new processing?" He replied that he hadn't actually touched the frame, but simply found an old TIFF file in the archive and resaved it in a different format. They didn't believe him. They went back to the conversation, pulled up his old post, and it was a different frame. Same date, same captions, same EXIF fields, but the old message had no halo. Where there was a faint green spot now in the updated photo, there had previously been just darkness. Similar stories were pouring out like wildfire. At one observatory, an operator swore that the overnight observation packet he'd left on the server was now a couple of gigabytes larger than it should have been. At another, they noticed that the control spectra of the calibration lamps had suddenly become cleaner, with the lines slightly shifted, but no one had touched the instrument, and the spectrometer had long since been out of warranty. Someone from the Hubble archive quietly sent me a screenshot in a private message. 2 JPEGs with identical hashes. One was downloaded a year ago, the other the day before yesterday. The bits match, but when displayed on the screen, they look different. Nothing dramatic, a subtle change in the background, slightly different noise, a barely noticeable hint of structure where there used to be a smooth gradient. "We checked," he wrote. "The files are identical, bit for bit. What's different is how the graphics subsystem renders them. It's as if the library that handles the interpretation was given a new dictionary for the same numbers. At some point, psychiatrists would call it mass apophenia. People simply began seeing connections where none existed. But the problem is that computers aren't prone to superstition. They honestly add up zeros and ones, and if a function has produced the same result for decades, and now produces a different one with the same input, it's not a hallucination, it's a change in the rules. We tried to replicate what we'd done with JWST and the ground antennas, but on a local machine. We took an old, completely isolated computer with no network, no updates, and a frozen system from 10 years ago. We loaded it with old Atlas observation files and had it render them using local software. The image looked familiar, no strange lines, no added halos. Then, across the room, there was a new terminal with the same set of files, but running a new operating system, and there, when displaying the same matrix of numbers, a subtle, barely perceptible, yet repeatable structure emerged. "The rendering protocol," one of the programmers said quietly. "The math is the same, but the interpreter changes. We wrote a simple test. We generated an artificial dataset, completely random noise, and ran it through both systems. The old computer produced pure white snow, as expected. The new one also produced noise, but with a slight, unpleasant feeling of being pulled towards certain patterns. It was as if a filter had appeared somewhere deep in the visualization library, subtly coloring areas falling within certain ranges. I asked, can we extract this filter? Build an inverse function and figure out what exactly it highlights? The answer was honest. Theoretically, yes. In practice, we'd have to disassemble the entire stack, from the graphics card driver to the last matrix operation in the graphics API. And even if we do, we won't be sure there isn't another layer hidden somewhere below at the microcode level. By this time, Atlas had already formally left the news cycle. The press had grown tired of the word interstellar, and people had returned to their earthly disasters, new missions, new scandals. But in the labs where raw data was still being circulated, no one was in a hurry to close the files. One young graduate student, the one who spent his nights running trajectory simulations on his home cluster, showed me something strange. He was modeling the ATL-AS hyperbolic flyby in various gravity fields, trying to slightly tweak the parameters of the Sun, Jupiter, and even the galactic potential to compare them with the observed coordinates. "Look," he said, displaying a set of curves, "if we use the standard model, everything fits perfectly up to a certain point. But then, as we approach the inner system, a systematic deviation of microscopic angular fractions appears in the data. We attributed this to noise, to measurement errors, but if we add another parameter to the model," he introduced a small correction term into the equations, a mathematical trick that in normal physics usually means we don't know what it is yet, we're just adjusting it. The deviation disappeared. "What is this parameter?" I asked. He paused. "Formally, it's a component very similar to a weak but structured change in the spatial metric along a trajectory. As if... like? It's as if the coordinate system itself had slightly bent to accommodate the object. It wasn't that it was flying along a hyperbola in our space, but rather that space had adjusted itself slightly so that its path would appear as a hyperbola in our equations. In normal times, phrases like these would quickly get you reminded you weren't in the art department, but after null, ant, task, and 3, after the black rectangle JWST, after ready on air, no one automatically objected anymore. A blasphemous thought increasingly haunted me. What if Atlas had never been an object in the conventional sense? Not a boulder, not an ice core, not a visitor from another system. What if it had originally been a procedure? A set of instructions deployed where there was a sufficiently complex surveillance network, a sufficiently dense shell of sensors and interfaces. In a distant, nameless system where there are no radio telescopes, digital cameras, or atomic clocks, such a comet would pass right through, leaving behind only a faint trace in the dust. There would be nothing to accept the protocol, nothing to update. But here, in a place where every point of the sky is saturated with sensors, where every microsecond is measured and recorded, its arrival triggers a chain of events akin to installing a new operating system layer on top of the old one. At one point, while leafing through old notes, I caught myself thinking another, even more unpleasant thought. We keep saying, Atlas came to us, as if it chose our system, our sun, our orbit. But the trajectory of an interstellar object is, first and foremost, statistics, randomness multiplied by time. But the fact that a global surveillance network had already been deployed here, billions of devices linked into a single field of perception, that's no coincidence. That's us. Maybe the real asymmetry isn't that something smart has arrived in our part of the galaxy. Maybe the asymmetry is that among the infinite number of places in the universe, it's here that someone has built a device capable of receiving and executing a command. Update, protocol, observation, layer. A comet is just a convenient package, a familiar visual marker around which we can spin beautiful headlines and write calm press releases. Doesn't pose a threat, will pass by, a unique opportunity for science. At one of the night meetings, when everyone was starting to feel the tension and was arguing more with their own fears than with each other, one of the colleagues asked a question that made the room suddenly quiet. Let's say that's true. Let's say Atlas isn't an object, but a protocol. Let's say it activated an update. How will we know it's complete? There were many answers, none of which were satisfactory. When anomalies stop appearing, when the data stabilizes, when new models begin to perfectly describe the observations, it all sounded decent, but empty. Because the real answer, which no one wanted to say out loud, was simple and unpleasant. We'll know the update is complete when we stop considering it an anomaly, when the new way of seeing the world becomes our only one. When no one remembers what the old spectra, the old sky maps, the old noise looked like. When records of strange rectangles and greenish halos seem like artifacts from an era of imperfect instruments. Someday, 10 or 20 years from now, someone will open an astrophysics textbook and find a neat chapter about 3I/ATLAS, the first interstellar object of this class, which allowed us to refine our understanding of the interstellar medium, demonstrating unusual effects in observational data, later explained by reworking the models. There will be a table with orbital parameters, links to articles, and careful words about contribution to the development of processing methods. The only thing missing is the feeling that at some point the night sky looked back at us. I still go out onto the roof at night and sometimes, out of habit, look up. The real sky isn't pixels. It's stubborn, cold, indifferent. The stars are still where they were before. The constellations haven't moved, and the moon still mocks me with its silent light. And yet, every time I see the faint trails of airplanes flying across the sky, the flickering of satellites intersecting with the invisible beams of radar and Wi-Fi, I think of another sky, the one that lives in our sensors, in our screens, in our models. The sky is an interface that someone has already updated once, without truly asking our consent. Perhaps this is the most terrifying discovery of the 3I/ATLAS era. It's not that somewhere out there, in the cold darkness, there are other objects, other civilizations, or other protocols. It's that the boundary between there and here, between object and observer, between space and consciousness, has proven far thinner than we'd hoped. And if someday, many years from now, another interstellar visitor enters our system and initiates its own update, we might not even notice it's changed anything. Because by that time, all our instruments, all our algorithms, all our familiar ways of looking up will already be operating within the framework of that same, once agreed, invisible agreement. An agreement that began with a green halo on old Hubble footage, a black rectangle on JWST, and one laconic line on the air.